All right, here we go. So today we're going to look at addition, subtraction, multiplication, and division of functions. Tomorrow we will do a composition of functions and spend 2 days on that. So for addition, f of x plus g of x. If I have f of x is 5x and g of x is x plus 2, this is just going to become 5x plus x plus 2, and there are like terms. Now when you subtract f of x minus g of x, you've got to be careful here. When you subtract a sum or a difference, you get 5x minus 2. So put a little star next to this one that with subtraction. If that second function is a sum or a difference, you're going to need to distribute. Multiplication, f of x times g of x. This is going to be 5x times x plus 2. And we know how to do that using the distributive property. It's 5x squared plus 10x. Division, f of x divided by g of x. This is just 5x over x plus 2. I'd like you to write a note down. You may cancel common factors not terms. Okay? You may cancel common factors, not terms. In the denominator of this fraction, the x is a term, so I can't cancel it with the x above it. Okay? All right, domain. Domain, remember, are values that you can plug in for x. So the x values that are in the domains of f and g, and does not include where g of x equals 0 in the quotient. So if you think about this, the domain of 5x is all real numbers. And the domain of g of x is all real numbers, because those are lines, right? Those are oblique or slanted lines. And so then the sum is all real numbers, the difference is all real numbers, the product is all real numbers, but when you're dealing with a fraction, look at 5x over x plus 2. What's the one number in the denominator I cannot have for x? What would make that 0 in the bottom? -2. So in this case, the domain would be x cannot equal -2, because that would cause it to be divided by 0. Okay? All right, I'd like you to, we're going to step off of the notes for a brief moment and turn to like your warm-up section where you can write some things out. We'll come back to this. But here's what I want us to look at. It says given f of x equals 3x plus 2 and g of x equals 4 minus 5x. I want to show you some notation that's commonly found. Maybe you'd see this on the ACT. Our book doesn't use it, but I just want you to be familiar, you know, if you're going to, when you go to college, if you take a college math class. They might say find f plus g of x. And that's just another way to say f of x plus g of x, okay? But I want you to get familiar with that notation. So if I want to do f plus g of x, which is f of x plus g of x, this is just 3x plus 2 plus 4 minus 5x. So that's -2x plus 6. In the second one, if I have f minus g of x, this stands for f of x minus g of x. So go ahead and do this one. Let me give you a head start. should be getting 8x minus 2. Okay, be careful with that distributive property. All right, f times g of x means f of x times g of x. So this would be 3x plus 2 times 4 minus 5x. So go ahead and do FOIL on it. So I'm getting negative 15x squared plus 2x plus 8. Did you guys get that? Alright, then f divided by g of x is f of x over g of x, which is 3x plus 2 over 4 minus 5x. Now since we just talked about domain, what would be the one number for x we can't put in that denominator? You just set the denominator equal to 0 and figure it out, okay? So you add 5x, and if you divide by 5, x can't be 4/5, okay? All right, then the last thing I want to do is look at what if you're given f of 2 plus g of 2? Okay, what if you're asked to input some numbers? Well, you come up to f of x and you plug in that x is 2, that's 6 plus 2 is 8. G of 2 would be 4 minus 10, which is negative 6. 8 plus negative 6 is 2. Sometimes you'll see it written this way, f minus g of 2. That means f of 2 minus g of 2, okay? Well, we already found those two numbers, so it's 8 minus negative 6, which would be 14. Okay, so just wanted you to see how it can be written perhaps in a different way. All right, back to our notes. We were up to the definition there. It says a power function is of the form y equals ax to the b power, where a is a real number and b is a rational number. All right, now you've talked about rational numbers since elementary school, okay? And then you do it in algebra, you do it in pre-algebra, algebra 1, and we've even reviewed it earlier this year, but we seem to be struggling. Can somebody in their own words state what is a rational number? Anybody give me an example of a rational number? No? Okay. Elena, what do you think?
That includes all the whole numbers and all the real numbers, and it also includes all decimals that terminate or repeat.
Okay, so it's all your whole numbers and integers, but it includes all the numbers that can be written as a fraction, and those include terminating and repeating decimals, okay? So a rational number can be written as a fraction. That includes terminating and repeating decimals. So if you think about 0.3 repeating, that's 1/3. But I can also do 1.5, that's 3/2, okay? So it's saying, but it's also integers, 1, 2, 3, 4, -1, -2, -3, and so on. Okay, so let's look at example 1. It says let f of x equals 3x minus 4, g of x equals x squared minus 2x plus 4. I'm going to give you a head start on me, and I want you to do A, B, and C. See if you're getting the hang of this now. Okay, so let's look at these three. Letter A, I got x squared plus x. B, I got negative x squared plus 5x minus 8. In C, remember you have to do that extended distributive property that you learned in Algebra 1. This is 3x cubed minus 10x squared plus 20x minus 16. Okay? Any questions now on adding, subtracting, multiplying, or even dividing functions? Okay, in example 2, now we're going to connect this to the power function and connect it to what we were doing in the last two sections with the exponent properties. So in example 2, if f of x is 4x to the 1/2 power and g of x is negative 9x to the 1/2 power, if you want to add these, it really is as easy as it looks. Excuse me. This is negative 5x to the 1/2 power. In letter B, you're going to get 4x to the 1/2 minus negative x to the 1/2. So that's 13x to the 1/2. Okay, pretty simple. However, it's asking me what are the possible values, what are the domains of f and g? So f plus g or f minus g. Well, recall that the square root of x is your x to the 1/2 power. To find the domain, of a square root function, you set the radicand greater than or equal to 0 and solve for the x, or solve for the variable. So, in each of these, it's the same thing. The radicand is what's underneath the radical symbol, okay? And so it's just an x, so it's x is greater than or equal to 0. That negative 5 and the 13 are not under the radical. You guys understand that, right? This is actually negative 5 square root x, and this one's 13 square root x. If they meant for the 13 to go underneath, there'd be a parenthesis around it, okay? Alright, example 3 says let f of x equal 6x and g of x equal x to the 3/4 power. Find the following. If you want to do f of x times g of x, now we're going to connect this to your exponent properties. 6x times x to the 3/4, you would add the exponents. And then remember, you need to build a common denominator. So this is 6x to the 7/4 power. Now something I need to tell you is that when you're determining domain and you have other roots, all of the even roots have to have a radicand that's greater than or equal to 0. So since it's a 4th root, the domain is x greater than or equal to 0. In letter B, if I do 6x divided by x to the 3/4, remember you subtract the exponents. Now what I just told you is that if you have an even root, it has to be x greater than or equal to 0. However, there's one extra thing to pay attention to. We have a fraction that we started with. And that means at no point can because I could be plugging in here or here, and it has to work in either spot. Do you guys realize that if I plugged in that x was 0, I'd be dividing by 0? And I can't do that. Even though it's simplified out, I technically could be plugging in here or here. So my domain on this one is going to be x is strictly greater than 0. So you have to be careful if your original problem is a fraction. that you have to keep in mind that the denominator cannot equal 0 there. Alright, so this can get a little confusing, alright? So if this is a little foggy, it's okay. We're going to keep working on it. We're going to spend 3 days on this section to help us. Alright, example 4 says f of x is 5x to the 1/3 and g of x is negative 11x to the 1/3. So if I want to add them, it is going to add nice and easy, and it will subtract easily as well. Now what's different is that these are odd roots. And I left this up from the previous class, is do you see I have x to the 1/3 is the cube root of x. I'm allowed to have negatives under an odd root. The cube root of negative 8 is negative 2. The cube root of negative 27 is negative 3. The cube root of negative 27 is negative 4. The problem with a square root, if I do the square root of negative 16, there's no real number that would work. Okay, do you understand? That's why I have to say for even roots, it's greater than or equal to 0. But odds are okay because the odds work. The odd roots work. So, what's nice about odd roots then is the domain will always be all real numbers unless it's in a denominator. Okay? So, let's look at example 5. If f of x is 8x and g of x is 2x to the 5/6, find the following. 8x times 2x to the 5/6 power. This becomes 16x to the 1 plus 5/6 and so that's 16x to the 11/6. Now the domain, it's an even root, but it's not a fraction. I mean, like, the problem is not in a fraction. So x is greater than or equal to 0. Letter B, f of x divided by g of x would be 4x to the 1 minus 5/6. So it's 4x to the 1/6. Now it's an even root, so x initially is greater than or equal to 0. But because we had a part where x was in the denominator, we can't have x be equal to 0, okay? All right, any questions up to this point? All right. Example 6, it says for a white rhino, heart rate R in beats per minute and lifespan S in minutes are related to body mass M in kilograms by these functions. R of M is 241 M to the negative 0.25 power. S of M, S of M equals 6 times 10 to the 6 times M to the 0.2. It says find R of M times S of M. So we're going to take 241 M to the negative 0.25 power times 6 times 10 to the 6th times M to the 0.2. If you have your graphing calculator with you, let me show you how we can enter. We're going to multiply 241 times 6 times 10 to the 6th. So we're going to do 241 times, I'm going to do a parenthesis, and then it's 6, and then do you remember we're going to use EE button. It's 1 above the number 7 under the comma. So you do second and the comma 6. Now, because I did this last period, go to your mode and change it to scientific, and then press enter. And you should be getting 1.446 E9. Now that's not how you're going to write it down, but So we're going to write 1.446 times 10 to the 9th. We're going to put it in a parenthesis. And then m to the negative 0.25 times m to the 0.2, you would add those exponents, and that's negative 0.05. Okay, so again, let me repeat what I've done. 241 times 6 times 10 to the 6th, and that's where we got this number from. And then I multiplied the variables. It says explain what this product means. In the situation, what would this give us?
Heart rate, beats per minute.
No, because R of M is the beats per minute. We're taking the beats per minute times the number of minutes in your lifespan.
So it's how many heartbeats you'll have this entire life.
Right, exactly. So this is the total number of heartbeats in the lifespan of a white rhino. Which is fascinating to think about, you know. Alright, then I wanted to get to example 7 today, which I'm going to, and then that's where we're going to stop. It says in example 7, use the result in the previous example to find a white rhino's number of heartbeats over its lifetime if the body mass is 1.7 times 10 to the 5th. So this is our 1.446 times 10 to the 9th. Then the mass is 1.7 times 10 to the 5th. And then we're going to raise that to the negative 0.05 power. So let me show you on the calculator how to enter that. So here we go. We're going to do parentheses. 1.446 E9, and then in a parenthesis we're going to put 1.7 E5, close that parenthesis, and then you're going to use your caret button. Okay, that's one above the divided by, caret, negative 0.05 power. So this is about 7.92 times 10 to the 8th heartbeats. Again, do not ever write on your homework, a quiz, or a test the E or EE button.